Finding slope given 2 points. A slope describes the tilt of a line, also known as its rate of change. Sometimes it's referred to as the rise over run, if you're looking at a graph. Sometimes it's referred to by its Greek letter, delta y over delta x. And sometimes we use this slope formula here on the far right. y2 minus y1 divided by x2 minus x1, or the difference of the y's divided by the difference of the x's. Now let's take a look at those x and y letters. When you're given a pair of points, they are written as an x and y pair. And when you have 2 points, it's difficult to tell them apart. So because we have 1 point and then a second point, we use these little tiny subscripts below the x and y letters. Since this red one is the first point, they both get this little tiny 1 here. And that helps us to separate which one is a number from the first point and which one is a number from the second point. For example, if you're asked to find the slope of the line that passes through the point 3, 7, and 5, 6, the first thing you should do is label point number 1 and point number 2. And it doesn't matter which way you label it, as long as the x and y both have a 1 here and the x and y both have a 2 there. Once it's labeled, it's easier to see where they go in this ratio, in this formula over here on the right. For some students, it's easier to write the points above and below each other like this in a stacked format, so that you can concentrate on pairing the y's together and pairing the x's together. Because if you put the numbers in the wrong place, you're going to get the wrong ratio. But every ratio starts as a giant subtraction fraction. So the first thing I'm going to do is I'm going to look for my y from my second point, which is 6. So that's the first number in the sentence of the numerator. Then I'm going to look for the y in the first point, and for us that's 7. So 6 subtract 7 is my numerator. And now I'm going to look at the points in the denominator. I need the x from the second point, which is 5, and the x coordinate from the first point, which is 3. Once I compute, I get my ratio. Now the same can be true if we're using stacked points. So I'm looking for the change in the y values, right? How does 7 become a 6? It goes down 1. And I'm also looking for the change in the x values. How does 3 become a 5? Well, it goes up 2. And when we put them in the right order in the ratio, we get the same fraction as we did when we used this formula. Let's try another one. Again, when you're given your 2 ordered pairs, the first thing you should do is label them. The first point is x1, y1, the second point is x2, y2. Or you could stack the points on top of each other. But either way, you always start with the same giant subtraction fraction. So I'm going to do my y2 minus y1 for my numerator, and then my x2 minus my x1 for the denominator. Now notice my x1 is a negative value. So I need to add that negative value here. The subtraction sign from the formula cannot be used as the negative sign for the 2. So now I have 8 minus negative 2, which makes 10. This fraction is correct, but I'm going to reduce it by dividing both the numerator and denominator by their greatest common factor. So this gives me a slope of 1/5. The same would be true if we use the delta y, delta x pattern over here for our stacked points. 2 to 4 is an increase of 2, and negative 2 to 8 is an increase of 10. 2 over 10 is the same as 1 over 5. Let's take a look at the next one here. Label your points first, or stack them one on top of the other. By stacking them, it helps you concentrate that these numbers are going to go in the numerator, and the x numbers are going to go in the denominator. But if you're using this formula here, you simply start with your giant subtraction fraction, and then put the right puzzle pieces into the right places. -3 minus -1, and then the denominator, I'm going to get -5 first and -2 second. There's a lot of negatives up in here, but whenever you subtract a negative, you're really going to add the opposite. That gives us -2 over -3, which can be simplified to +2/3. All right, in our next example here, we're going to get a special type of solution. So after I've labeled my points, and I've set up my giant subtraction fraction, and I put my y2 and my y1 together, and my x2 and my x1 together, I'm going to get 0 over -3. And anytime you have a 0 in the fraction, whether it's in the numerator or whether it's in the denominator, you have to go one step further. You have to define it as either a 0 or whether it's undefined. So a 0 in the numerator means you have a slope of 0. 0 in the denominator means something else. And for this final example here, once we set up our giant subtraction fraction, we put our parts in the right places. The y's go in the numerator, the x's go in the denominator, and this time I get 8 over 0. And I can't stop here. If you have a 0 in your fraction, you have to interpret it. Remember, a 0 in the numerator is a 0, but a 0 in the denominator is undefined. And that's how you find the slope when given 2 points.